Last time, we introduced the concept of prefixes and how they apply to the units of measurement in the metric system. We learned that kilo equals 1,000. And each time we use one of those prefixes, we're linking it to the base units. So if our base unit is a meter, a kilo equals 1,000, and a kilometer equals 1,000 meters. We applied that to a hectometer and said hecto is 100. A hectometer equals 100 meters. We did the same with a millimeter, a centimeter, and a decimeter, each one of those being 1 1,000th, 1 100th, and 1/10 respectively. Today we're going to start with base units and convert them to units of measurement that are larger than the base unit. For example, taking a meter and converting that to a kilometer. And we're going to take our base units such as a gram, a liter, a meter, and convert that to smaller units such as a millimeter.
There's a wonderful world of chemistry. Anywhere you wander, thousands of sights, all pure delights, stretching from here clear to yonder, in the wonderful world of chemistry, beginning now.
Hello everyone, welcome to World of Chemistry. I'm your hostess, Jackie Clancher. Today we're going to continue on with unit conversions within the metric system. What I'm writing here is the exponential escalator, and we're going to use this to help us visualize metric conversions. Once you're adept at that, we're going to bring in those exponents and look at the metric system slightly more mathematically. But for now, all you need to do is get on the escalator and ride. So where I am now is what we'll call home base. This is my base unit. It can be a meter, a gram, or a liter. But we don't always use base units. We want to discuss things in terms of measurements that are much smaller and much larger. So let's begin with the unit conversion. For now, I'm going to focus on the meter used to measure length. Right now, I'm going to tell you that I have 1.00 meters, or 100 centimeters, or 1,000 millimeters. Okay? We learned that last time, that they all intertwine in the powers of 10. So here I am on my base unit, 1 meter. But you've been asked to convert for your important job, or for your homework, or in the lab, to take 1 meter and convert it to a kilometer. No need to panic. Everything within the metric system functions on powers of 10. And on the exponential escalator, we can move to the left or up the stairway, in which case we move our decimal to the left and make our number smaller, or to the right and down the escalator, wherein our number gets bigger. Let's take a look at that in action. I begin again with 1.00 meters. How many decameters would 1.00 meters be? We already know that a decameter is 10 meters, so hence 1 meter is 1/10 of a decameter. What does that mean for us in the exponential escalator? It means when we move to the left, up the escalator, we're going to take our decimal place and move it 1 point to the left. So 1.00 meters. So when I move up the exponential escalator to a decameter, we already know that a decameter is equal to 10 meters, but I only began with 1 meter. So 1 step, 1 decimal place movement to the left, making your number smaller. When we move up the exponential escalator to hecto, again, we go up the stair and our decimal moves to the left, essentially making our number smaller. So we began with 1.0 meters. We said 1.0 meters equals 0.1 decameters, and we move up 1 more step. Our decimal place moves 1 more to the left, and we have 0.01 hectometers. What happens if we move up 1 more step to kilo? we know that kilo equals 1,000. 1 kilometer would equal 1,000 base units, but we only have one. So now 1 meter is 1/1000th of a kilometer, or 1 over 10 to the negative third, or 1 over 1,000. So what does that mean for our number? It means now we take our decimal place and move it 3 places to the left. So now we've arrived at the kilometer. We've taken our base unit of 1.00 meters, moved it up the exponential escalator, 1, 2, 3 spots. Each time we move up a step, we move our decimal place 1 point to the left. So 1 meter equals 0.001 kilometers. Let's take that and go back down to our base unit. Back down from 0.001 kilometers to 1.00 meters. Now we can do the same thing on each of the subsequent steps going down. This way, comparatively, seems almost easier. I had 1.0 meters, but now I want to express it in terms of a decimeter. You know that a decimeter is 1/10 of a meter. Hence, if I take 1 meter and divide it up into smaller pieces, it's almost like the number gets bigger. What do I mean? 1.0 meters, moving down 1 step on the exponential escalator, takes 1.0 meters and gives us 10.0 decimeters. So 1.0 meters converted to decimeters goes from 1 to 10. 1 step, 1 decimal place to the right. It's like our number gets bigger. Decimeters convert likewise to centimeters. We began with 1.0 meters. We said we now had 10.0 decimeters. How many centimeters would we have? Well, a centimeter is 1/100th of a meter, and I had 1 full meter, so I now have 100 centimeters. 2 steps, 2 decimal places, 2 zeros added. It's like the number keeps getting bigger. We go from centi at 100 centimeters, and I ask you to express this unit of measurement in terms of the millimeter. You know that a millimeter is 1/1000th of a meter, but I've told you I've got a meter, so I hence have 1,000 millimeters. Each step up the exponential escalator hence moves our decimal place 1 place to the left. Each step down the escalator moves our decimal place 1 point to the right, and the number gets larger.
You can either go out that window or take the stairs.
Okay, yeah, we're gonna take the stairs. Yeah, we'll take the stairs.
So let's mix things up a little bit. And this time, instead of discussing length, using the meter as our base unit of measurement, let's discuss mass. And let's start with the base unit of the gram. Also, to spice things up a little bit, let's start with more than just 1 gram. Let's start with 1,230 grams of sugar. Here I am, my base unit. I want to know if I have 1,230 grams of sugar, how many kilograms I have. You know now that kilo equals 10 to the third, or 1,000 base units, and you know that each time you move 1 step up the staircase, you need to move your decimal place to the left. So we began with 1,230 grams of sugar. How many kilograms do we have? We need to move our decimal place 3 places to the left, and we have 1.23 kilograms. Now, how about if we were speaking in terms of decagrams? So let's say we wanted to convert kilogram to a decagram. This time we needed to move our decimal place 2 steps to the right, making our number essentially bigger. So we had 1.230 kilograms. How many decagrams do we have? 123.0. Now, if I told you I have 123.0 decagrams of sugar, but I wanted to know how many hectograms I had, this time we move our decimal place again to the left, one spot. We go up the exponential escalator and we take 123 decameters, convert it to hectometers, and we get 12.30. All part of riding the escalator. Let's pop down to base units again, and this time let's look at the liter. So this time we're going to measure volume, and we're going to start with the liter. Liter is commonly used. You have a 1.0 liter water bottle, as is the milliliter, also very commonly used. So let's begin this time with a 1 liter water bottle, but it has just a little extra. It's just a smidge extra in the lid, 1.123 liters. Let's convert that to milliliters. This time we took our liter from the base unit and went down the exponential escalator 3 steps, 1, 2, 3, arriving at the milliliter. So what happens to our number? We know we went down the staircase, the number gets bigger. We went from 1.123 liters to 1,123 milliliters. Let's say you needed to know for some reason how many centiliters were in 1,123 milliliters. Back up the exponential escalator, 1 step. You have 1,123 milliliters. How many centiliters? You have 112.3 centiliters. All we did was move our decimal place 1 spot to the left as we moved up the exponential escalator. It's that easy. It's time for some contemplation and reflection. Sing!
Centi turns to milli and kilo to hecto. Just move the decimal to the right and watch the number grow. Move the decimal to the left, the number will grow small. This is a lesson from the metric system that should be known to all. When it's time to change, although it may seem strange, move the decimal right or left and feel the zen. When it's time to change, you've got to rearrange. Every number can be converted using about 10.
There's a wonderful world of chemistry. Anywhere you wander, thousands of sights, all pure delights, stretching from here clear to yonder. In the wonderful world of chemistry,